Welcome to Eeci TRB Polytechnic EEE solutions. Okay, we are addressing 2 marks. Let us get into the next interesting 2 marks problem. That's well connected to the electrical core. Okay, so a little bit of power electronics you can think, but simple basic analog electronics alone will help you to complete this problem. Okay, so what's given is, first understand what is given. So what is the time required T needed to deliver a charge of 200 ampere hour? Okay, 200 ampere hour. Okay, so remember a 1 coulomb charge is nothing but 1 coulomb per second is nothing but 1 ampere. Okay, so therefore 1 coulomb is nothing but 1 ampere into second. So the current into time will be automatically a charge. Okay, so it's making sense. So it has to deliver. We have some element like a charger. It has to deliver a charge of 200 ampere per hour through a single phase of a rectifier, diode rectifier, with an output current of 100 volt or 100 amps RMS with a sinusoidal excitation to the off wave rectifier. So how much time you really need, okay, to deliver a charge of 200 ampere hour for a battery, for example. Okay, so assume the charging device is a battery. You are charging a battery. Okay, but you have to supply what energy, what charge means you have to have 200 ampere hour. Okay, charge it has to be delivered to this battery. Okay, what we have as a device means we have one off wave rectifier that is excited by a sinusoidal source, but no information about it, not required, but because output uh, information is given for the off wave rectifier. So we have an AC source, some Vm sin omega t, no information given about this. Okay, not required also to answer the problem. So that's connected to the input terminals of a rectifier. Then it is producing an output. Okay, either you can treat a single output or a dual output. So this is plus minus, not a problem. Okay, so what we have is talking about when connected. Okay, like this. Okay, you need to imagine this. Then there is a current. Okay, there is a current. Okay, charging the battery. That current RMS is given. What is that? RMS current magnitude 100 amps RMS is given. This current has effective value of 100 amps. Okay, so 100 amps RMS current is charging the battery. So you have to deliver, the off wave rectifier has to deliver 200 amps hours of charge to the battery. So how many hours it needs? All are given in hours only. How many hours you need to charge a battery, or the off wave rectifier will deliver a charge of 200 ampere hour in the charge flow, okay, from off wave rectifier to the battery. So the question is the time. So we'll see how to play for this time. So what is given is the current RMS of a rectifier is given. What is the current RMS? It's 100 amps RMS current. So let us plot the off wave rectified signal current profile. So this is a current profile I of t. So this is going to have something like this. That's a 0 to pi positive of cycle, then no rectification from pi to 2 pi. Again, the half cycle gets repeated from pi to 3 pi, 2 pi to 3 pi. So this is how we get the off wave rectified signal. Excuse me. What is given is the RMS value of this pulsating DC is given. So what is the RMS value? And hope you remember the RMS value of an off wave rectified signal is equal to IP by 2. That's where the problem begins. The RMS value of off wave rectified signal is with respect to the peak is IP by 2. If it is full wave rectified, IP by root 2. If it is a pure sine wave, there is also IP by root 2. Remember, if we have a full wave rectified signal, this is going to give IP by root 2 as its RMS. Even if it is pure sine wave with a peak current of IP will give IP by root 2. Okay, there is a chance of committing a mistake here. So we should take IP by 2 as the RMS. So this is given as 100 ampere. So therefore, what will be the peak current? The instantaneous peak current is going to be 2 times 100. That's going to be 200 amps. So your off-air rectified signal whose RMS value is given, the current value which is charging the battery is given as 100 ampere RMS. So what is actual peak current means? It is going to have a peak value of 200 amps. So this is the current profile charging the battery. So this is what we have. The battery demands a charge of 200 ampere hour. So you have to deliver 200 ampere hour to the battery means that's your battery. So how many hours you will deliver this? So this is the current, okay, making the charge flow. So what is the current? Amplitude peak 200 amps. 200 amp peak current is going. So now tell me in what time you will get 200 ampere hour charge for the battery. Yes, it's very easy. So then feel like it's a DC current. So go for the average of this off-air rectified signal. What will be the average? So that's what your average, you can call it as a IDC. Okay, so what is that? IDC will be equal to, it is average of a off-air rectified signal is IP by pi. Exploiting this, the average current will be equal to, so it is 200 ampere divided by pi. Okay, so that's a current it is delivering. So by using this current, we have to deliver a charge of how much? 200 ampere hour we have to deliver. Okay, ampere hour, let me take formally. So by charging for how many hours with this current, you will deliver a charge of 200 ampere hour means, so it is 200 by pi is the current ampere. Okay, so 200 by pi ampere, and how many hours you need to deliver a charge of 200 Ah. Yes, what is the only unknown? Hour is the only unknown. Yes, problem is straightforward now. So then the 200 will get cancelled. Okay, 200 amp will get cancelled. Then what is the remaining means? The X hour or T hour needed is going to be, so number of hours needed is going to be pi hours. It's going to be pi hours. So the answer is this. Okay, so there is a chance of, okay, so taking this data 100, so 100 amps RMS is not your peak. It is nothing but your IP by 2. So then you have to take IP by 2 is equal to 100. Then IP becomes 200. From this, you have to go for the average or like a DC current delivered by the off-air rectifier. Then go for your charge. Okay, delivered in the given time. So you can go for the time. Suppose if the time is pi hours means it is nothing but 22 by 7. So it is nothing but, hope you remember, pi value, that is 3.14. So the answer is 3.14 hours. Okay, so just multiply 200 into 200 by pi into pi is going to be automatically 200 Ah. That's a very simple, interesting problem connecting to the practical way of getting charged by the battery, getting charged by the off-air rectifier. If it is fully rectified, things will change, calculations will change. Okay, because average will be double, even RMS expression also little different for a full wave rectified signal. Okay, so that's an interesting aspect of the problem. So the right answer should be 3.14. Okay, that's a option. The correct answer is option C. Okay, so stick to the fundamental. Okay, so of a rectification and RMS of a rectified signal and average of a rectified signal. There is less chance of committing mistake and problem is straightforward, and probably more than 50% of GATE or IES aspirants. Okay, so almost all the GATE or IES aspirants might have correctly attempted this problem, hopefully. Okay, right? And even TRB aspirants alone practiced to this level might have connected to this level. Okay, that's a fundamental. Okay, so there is not, it's not a formula based. Yes, there is a formula we need to use only for the off-air rectifier, for the RMS and average. Once you know that, yes, it is connecting to the logic given in the problem. Okay, so thanks for watching. We'll update you with one more video soon.